Hello and welcome, everyone. My name is Dane Menke. I am the Digital Marketing Manager here at Regenesis and Land Science. Before we get started today, I have just a couple of administrative items to cover. Since we're trying to keep this under an hour, today's presentation will be conducted with the audience audio settings on mute. This will minimize unwanted background noise from the large number of participants joining us today. If you have a question, we encourage you to ask it using the question feature located on the webinar panel. We'll collect your questions and do our best to answer them at the end of the presentation. If we do not address your question, we'll make an effort to follow up with you after the webinar. In order to sponsor events that are of value and worthy of your time, we will be sending out a brief survey following the webinar to get your feedback. Today's webinar will focus on the vapor intrusion risk pathway, regulatory updates, and hot topics. To give us insight into these topics, we are pleased to have with us today Dr. Blayne Hartman of Hartman Environmental Geoscience. Dr. Hartman is a nationally recognized expert on soil vapor sampling, soil vapor analysis, and vapor intrusion. He has provided training on soil gas methods and vapor intrusion to state regulatory agencies in over 30 states. His organization, Hartman Environmental Geoscience, provides vapor intrusion, soil gas and analytical expertise, and specializes in VI and soil gas training, real-time continuous monitoring of TCE and other VOCs in indoor air, and vapor intrusion regulatory guidance. We also have with us today Hieu Nguyen, Senior Research Engineer at Land Science. Hieu oversees vapor barrier product implementation at construction sites and provides technical support to regional and district managers, as well as Land Science clients. He offers 10 years of experience supporting brownfield redevelopment project designs, specifications, and installations across the United States, Canada, and Australia. He is also an active member of the ITRC Petroleum Vapor Intrusion Task Group and ASTM. All right, that concludes our introduction. So now I'll hand things over to Blayne Hartman to get us started.
Okay, thank you, Dane. Hi to everyone out there. We got a large crowd that's signed up and going through the pre-registration list. I saw a lot of familiar names. Thanks to all of you for attending, and hi to all those of you who I've met before. Okay, I'm going to talk first about regulatory updates. In fact, that's where I'll probably spend most of the time this morning. And then the hot topic that I'm going to cover and show you lots of data from various sites is on VOC monitoring that we've been doing over the past year or two. Now, as is typical with me, I have a lot more material than time I'm allotted for, so we'll proceed down the course here, and if I run out of time, then I'll just button it up real fast and you can ask questions. All right, so let's start with the regulatory topics. Now, when I did this webinar a year ago, and the last couple of years, I list what I call the hot topics, and some of those hot topics on the regulatory side were the guidances that came out from EPA, both from OSMR and OUST. Well, you see now I've kind of recategorized it. I've called it now getting cold, and the reason for these topics under the getting cold category is they've been out there for a while. And so we're getting used to working with them, and so they're not quite as causing so many issues for us to deal with in the vapor intrusion world. So OSMR and OUST, and I'll go through a quick summary of those, and then the ASTM Phase 1 standard, the ITRC PVI. So I'll go through those very, very quickly because I really want to focus on what I still consider to be red hot regulatory topics. Now, the first one is use of models, or should I say lack of use of models. So I'll go through that with you quickly, and then I'm really going to spend the time on the short-term TCE exposure issue, which has been a hot topic now for 2 or 3 years. It remains a hot topic, and there's some interesting twists that have been coming up with this pathway over the last year or so. All right, so let's take a look at the EPA guidances first. Again, this is going to be a summary of presentations or issues that I've brought up over the past 2 or 3 years. And when I've done that, those of you who have listened in, I've kind of summarized the guidances going back to an old movie, The Good, the Bad, and the Ugly. And so what I've done is listed some bullet points that I kind of consider to be good and bad and, should we say, ugly about the guidances. So first, the OSPR one. Again, it's a little bit getting cold, as I put down, because it really came out over a couple of years ago. So I think the environmental community practitioners are getting used to it. To me, a couple of the good features of it was it talks about the fact that you don't need to test for all 80 or 90 or 100 compounds on a site. You can limit your test to the compounds that you have a prehistory with, knowing that they've been on the site. So that's a good thing. But what I do want to say to you is that when laboratories do these TO14, TO15, TO17 analyses, you might tell them to only sample for or report 5 or 10 compounds, but they still are measuring all 40 or 50 or 60, whatever is on their compound list, which you can always go back, call them up and ask for down the road. So keep that in mind, that if you only have them report a subset, and if for some reason a year later or whatever you need to have more compounds looked at, the laboratories have the ability to do that. All right, the second, what I say good bullet or good part of the regulation is they say throughout many, many, many times that it's technical guidance. It's not regulation. So that means you as a practitioner have flexibility to do, so shall we say, different approaches that are not necessarily written up in the guidance. You're supposed to have flexibility. Okay, what are some of the bad things? Well, the first bullet is the preference for soil gas samples collected near the source. Now, that's a terrible idea for hydrocarbons. That's what's in red. Terrible for HCs. HCs are hydrocarbons. And the reason for that is if you sample down at the source, 10, 20 feet down, 30 feet down, whatever, then you're ignoring that hydrocarbons bioattenuate in the vadose zone. And so what you measure down deep may have very little to do with what's actually near the structure itself. So not a good idea. The second bullet is the guidance really prefers to have longer indoor air sampling periods, generally using, say, passive collectors. Although now with Summa canisters, by the way, you can collect samples for 7 days to 14 days with canisters. A lot of people don't know that. That technology exists. But again, the big problem with that, and I put in red, terrible for hydrocarbons again, is that we then start to see a lot of compounds, a lot of detections of compounds that are in everyday products in the home, especially for hydrocarbons. Hydrocarbons are in just about everything you use, including shaving cream, shampoos, candles, pan spray for when you're cooking, all kinds of things. So if you're doing long-term sampling for hydrocarbons, you're going to get all kinds of detections, and you're never going to be able to sort out where they're coming from. It's very difficult to sort it out, we should say. And then the last issue is this fixed attenuation factor of 0.03, and I'm going to get into that in the next couple slides. So that's what I consider some of the not so good or the bad parts of the guidance. And then there are some ugly parts. One is that this guidance applies to non-UST petroleum sites. And that's a real problem, again, because of look at the bullets above where I talk about terrible for hydrocarbons, terrible for hydrocarbons. So it's not the best guidance to use on petroleum sites, period, whether they're UST or refinery sites or whatever, but it applies. The second is that this guidance goes to, in many cases, their justification of being applied to businesses in lieu of OSHA. And of course, the issue there is that the levels that this guidance uses, risk-based levels, are thousands of times lower than OSHA levels. So that's a real problem for businesses. And then the last, what I call ugly aspect of the guidance, it's just not easy to read. It's very, very, it's not the best organized document I've seen. There's so many footnotes and references out that I find it very difficult. So it's just a difficult read. I find it to be very unclear in a lot of places. So the ramification of this guidance document is it's going to cause confusion among practitioners. It's going to complicate vapor intrusion assessments. And that has been what I've been seeing. All right, now we jump on to OUST, Office of Underground Storage Tanks. Again, came out in June 2015. The good. It includes exclusion criteria for groundwater and soil, the soil in red with double exclamation points. There's a reason that I point that out, which I'll show you in the next slide. It's concise, it's broken into sections, and each section is a separate topic. So the organization is good. You can get through it very, very quickly. You can get to the points of your specific interest very, very quickly. Some bad. The lateral exclusion distances, the distance away from the contamination that you can essentially screen out the vapor pathway, is different than the vertical exclusion distance. So that complicates things. The second, say, bad item, they don't give any screening levels. For soil gas, they say to calculate them use an attenuation factor, and that gets us down to that, what I consider maybe the one ugly portion of the guidance, is that they want you to calculate screening levels from the attenuation factor, but then in section 12 and section 13, they have some contradictory text about how to do that. Having said all that, though, this guidance, the ramification will be, it's a positive, it will reduce the number of sites of petroleum vapor intrusion sites that have to worry about the vapor intrusion pathway. So it'll reduce the number of PVI sites, we call them. All right, this is a slide showing those exclusion criteria. For those of you who are not familiar with them, this is out of the EPA House guidance. It's table 3. If you're not familiar with this, take a look. But basically what this does, there's a row for soil in light brown, there's a row for groundwater in blue. That colors seem to match up with soil and water. And basically what this exclusion criteria are is that if the concentrations are less than those in this table for benzene and TPH, and there's a separation distance over to the right, which is greater than those listed there, then essentially what you can do is you can exclude the site from the vapor intrusion pathway assessment. The way I like to think about it is you can throw the site essentially for the vapor intrusion pathway into the out basket. All right, but there are some criterion that you have to meet to apply these criteria, these exclusion criteria, and that is you must have clean soil. All right, well, here's our inbox, outbox. I do like this graphic, Dane. We just put this in before we started the seminar. So this is the idea, is that for PVI sites, if you meet those exclusion criteria, then you can put those files or those sites into the vapor intrusion outbox, which is kind of nice. So I've listed here some of the states that I know have adopted exclusion criteria. There could be more than this list. This list I don't believe is complete. So for those of you listening out there, if you don't see a state, if you do not see a state that you know has adopted exclusion criteria, please send me an email and say, you know, this state has adopted them, so that I can update this list for the next webinar that I give. All right, so that's the quick summary of the Osborne House guidances. Now, ASTM, again, cold. The phase 1 standard that really came out a couple of years ago and now is in effect. Vapor migration is now an environmental condition. The screening distances are very long. Look at the one for petroleum hydrocarbon, PHC, that says 528 feet. Well, if you use the exclusion criteria that I talked about before, it can be as short as 6 feet. 6 versus 528, that's almost a 100-fold difference. In other words, the nets are very, very wide in the ASTM standard for having to take a look, at least take a look of screen the VI pathway as being a potential concern. And so because of that, the last bullet says a lot of sites will not be closed because of those large screening distances that are shown in the second bullet. And the ramification of that, the result of that, for those of you listening, is, well, there's going to be a lot of sites that probably will need a lot more consulting time. So those of you who are consultants out there should have a big smile on your face right now. ITRC has come up with their petroleum VI guidance. It's actually kind of old now. It's 3 years old in October. So here's a list of what's in it. You can get it by going to their website. To me, the most valuable parts of it are number 5, mitigation. There's a very complete section on mitigation, which is a good one for those of you who are at sites where it needs mitigation. And then the next part of it, which is very good, is the appendix called the toolbox, which gives you very detailed well, a lot of details, I should say, on sampling and analysis methods. Sampling methods meaning soil gas methods, indoor air methods. So that is a very big resource for those of you who are doing vapor intrusion assessments. All right, and they've been given a classroom training. In fact, there's one coming up, which I'll tell you about later on at the end. All right, so that's kind of the cold topics, or the getting cold regulatory topics. So let's go to what I consider to be the hot ones right now. So the first one I want to talk about is modeling getting the boot. So I hope you kind of like this graphic. I've listed here some of these states that I know that have essentially shied away from allowing models. And again, for those of you out there, this is probably not a complete list. So if any of you out there know of other states that have gone away from modeling, please let me know. There's a lot of regulators on this call, on this webinar. I know from Washington, Georgia, probably all these states listed. In fact, if indeed I'm incorrect in listing you, I don't believe I am, but if I am, please let me know so I can get it right. So no more Johnson-Ettinger modeling in many states, certainly with EPA. Instead, they want you to use a calculator, essentially an Excel spreadsheet, which is called the Vapor Intrusion Screening Level, VISL calculator. The VISL, that's the new acronym for the vapor intrusion world. The VISL. Are you using the VISL? All right. Which brings us to this next slide, which is the mysterious 0.03. Now, what do I mean by that? Well, the first part of this is a text, which is just the title of this EPA database report on attenuation factors, which came out in March 2012. So those first 5 lines are the title of the EPA document. That's all that is, except that I have taken the liberty to underline and put in red color residential. This is the database for the attenuation factor development evaluation that EPA did for residential buildings. Now, the first bullet says, okay, what does it say? What's the summary of that document? Well, it says the 95th percentile of residents with basements, the attenuation factor that they came up and evaluated was 0.03. So there's the 0.03, the mysterious 0.03. But look at the second bullet. The second bullet says, if you look in that document, that for slab on grade construction, the 95th percentile is 0.01, the attenuation factor. Well, of course, that begs the question, then why is the EPA, the VISL calculator, and why are the states using the VISL calculator, why are they applying 0.03 to all structures, right? If it's a slab on grade, it should be 0.01 if you're going to follow this document. And these are only for residential structures. There's no commercial structures in this database. So these two attenuation factors, 0.01 or 0.03, may have absolutely no bearing to a commercial structure. And in my experience, doing indoor air and subslab at commercial structures, generally the attenuation factors I see are a good 10 times lower, 10 to 30 times lower than the ones listed here. So what do I do then? Well, right on to the rescue. Whenever I'm doing subslab sampling, especially in a commercial building, but even in residential, I always collect samples for radon so that I can determine from the radon a site-specific or building-specific attenuation factor rather than use these very, very conservative defaults. So that's what I mean by the mysterious 0.03. Why are we using it for slab on grade, where clearly the database report referenced up there at the top says 0.01 is the number to use? And why are we using this for commercial buildings? So for all the regulators out there, and there's a bunch of you, I'm happy you're listening. I challenge you to say maybe you should think about upgrading some of those specifications. Okay, hot topic number 2, good old short-term TCE. Now, this is it's been a hot topic for a few years. We're talking, of course, for those of you who aren't familiar with it, I bet most of you are, we're talking about malformation of the heart in the fetuses, of course, of pregnant women. So hence the picture of the pregnant woman, and hence the picture of the heart with the Band-Aid on it, the damaged heart. All right. Region 7 came out about a year ago now, November 2016. This is their text, except I've underlined and put those three words in red. It is assumed that exposure to TCE at any time during the 3-week period, at any time, not for the whole 3 weeks, but at any time. And so then they go on to say that the allowed level for a 24-hour period, residential, 2 micrograms per cubic meter, and for commercial, 8-hour exposure, 6. So basically what they're doing is saying 48 micrograms of TCE is a level of concern. 2 times 24, 6 times 8. And they even give an equation where you can do the calculations yourself. It's right in this document. So that means to me, or the question it raises in my mind is, well, 48's the micrograms that you could be exposed to, and in one case over 24 hours, the other case over 8 hours. So does that mean that 48 micrograms per cubic meter over 1 hour would be considered to be a problem, to maybe result in an issue? Well, then following that forward, then would it be 96 micrograms for 30 minutes? And then if following that forward, what about 480 micrograms for 6 minutes? And as I ask this question around the country, I don't seem to be getting a very consistent answer to that question. All right, well, I just figured I'd try to make this slide and come up with the topics being kicked around on there on all the news stations. So real news or fake news? The Johnson et al. Study. All right. Turns out that the Johnson et al. Study is what this short-term TC issue is being based upon. Well, for those that I've listened to a lot of people talk about, the toxicologists that know this better than I, but basically the study that the short-term TC exposure levels are based upon is based on oral exposure. Notice that I put that in red. It's not based on inhalation. The second issue about this study is that they have not been able to reproduce the study, which I put in red. Fetal heart malformation results not replicated in 5 other inhalation studies. So if that's the case, if this is based on oral, not inhalation, and if they can't reproduce the study, that makes me wonder, then why are all these agencies, EPA and all these states, adopting this standard? Why? Well, I can only think that maybe Boris and Natasha are behind it. Just fooling. I hope you like that, though. Okay, so that point aside, whether it's a study that should be relied on or not, and it turns out the solvent industry is redoing a study as I speak. They are redoing a study to see if they can replicate the Johnson study, and they're doing it based on ingestion, not inhalation. So they're trying to reproduce that study. We had hoped that we'd have results by the time this webinar was held. Unfortunately, I guess their first crack at it, they had some issues that didn't quite work out. I'm not sure the details. So apparently they're starting the study again. So hopefully we'll have that by the end of the year, and then maybe that'll shed some light on whether it's whether the Johnson study the results are ones that we should adopt or not. But in the meantime, what's going on is this. So here's a letter from the Massachusetts DEP. I put in the red box. They're screening 1,000 closed sites. They're basically looking at closed sites again to see if they need to look at trichloroethylene. And then down below, you can see that the levels of concern prior to 2011, prior to 2006, have dropped by 14 to 60 times, depending on when you look there. So in other words, they're reopening sites and they're looking at levels that are 14 to 60 times lower than they were looking at before. A lot more sites are going to obviously screen in for evaluation. This came out in May. Michigan Department of Environmental Quality, there's a lot of them that signed up for this webinar. This is their text that came out, not my text. I just put some of it in red. They announced they will be evaluating vapor intrusion pathway at 4,000 sites. And then, of course, below it says, with lower screening levels, this means more sites will likely require detailed VI evaluations. States reopening the TC sites, kind of states jumping on the TCE short-term bandwagon. There's the ones I know of that are doing this. There could be more, once again, and if there are, please let me know so I can update this slide. What's the result of all this? Reopening sites with lower screening levels for you consultants? Well, there it is again. There's the money tree. It means a lot more billable time. So if you're a consultant, you're probably smiling. If you're an RP, and I know we have some auto companies and some chemical companies that signed up for this, you're probably not smiling. And if you're a regulator, well, I guess you'll be overseeing a lot more sites. All right. Now, some agencies have come out and taken this a step further, and they've come out with rapid response levels now, or urgent response levels, where we have to take some action very quickly. Now, a lot of states have done that for indoor air levels, a lot of states. But some states, the one I'm showing here is Ohio, have actually come up with rapid response or urgent response levels where you have to go out within a few days based on groundwater concentrations. So here's Ohio EPA's, look to the right, look to the bottom right, within a few days you have to do something at these groundwater concentrations. And then they've even done it for subslab soil gas. Again, within a few days, you have to go out and do something, even if it's accelerated, which is to the column to the left, within a few days to 2 weeks. So basically, these new standards mean that you have to get out there within a few days to 2 weeks based on groundwater and subslab soil gas concentrations, taking it to a whole new level. What are some of those urgent response actions you can do? Well, you can throw air filtration units in to a house or to a structure or to a room. You can modify the HVACs. You can seal floor cracks and hope that'll do it. You can continuously monitor to determine how often it's above the target level, or you can relocate people, which of course, once you do that, then everyone wonders why you're relocating me, so that could open Pandora's box. Air filtration, I'm going to show you the next few slides, doesn't always cut the levels low enough. Same with sealing floor cracks. HVAC modification can take time. Relocating people can cause a lot of Prozac moments. Believe it or not, using these monitor, the continuously monitor, might be a nice solution for short-term solution for urgent response. All right, so how do we then assess the TCE short-term, whether we have a TCE short-term issue in indoor air? We can use passive collectors, but there's a lot of problems with them, which I've listed here. I'm not going to go through it one by one for interest of time. But passive collectors, in my opinion, are the poor man's way of trying to really get a handle on the short-term TCE issue for the list of reasons here. Or you can use continuous analyzers, which basically means you're getting high-resolution data. So here's the continuous monitoring system that I like to use. Gas chromatograph equipped with a variety of detectors, principally the electron capture detector, but sometimes we use other ones depending on the compound. It's technology that's been around for a while. I've been using it on a lot of sites over the last few years. All right, so how do we apply this continuous monitoring system? Well, if we're worried about short-term TCE exposure, well, certainly we can monitor. We get an analysis every 10 minutes. So we can look at what the concentrations are over a period of hours or 24 hours or a few days or 21 days, that range of time that the different agencies believe can cause a fetal malformation. By having high resolution data, we can tell how often a building is above the safe value. Is it above the value an hour a day, 5 hours a day, all day? And we can also look for spatial variability in a building. We can use it to identify VOC entry points. I'm going to show you data for all these real fast. And then once we feel there is an issue, then we can monitor why modifications are made to a building. Turn on fans, open doors, change the HVAC, seal the cracks. All these things with the system running can give you instant feedback on whether those changes you're making are essentially cutting the levels down, the indoor air levels down to acceptable levels. So now I'm going to run through, I got about 7 minutes left, and I'm going to run through some examples really, really quickly. By the way, I meant to tell you that this presentation is posted on my website. You'll be able to get it, it's already there, and I think they're going to post it probably on the Land Science website. So very quickly, let's assume this is a site where we're measuring indoor air, actually of PERC, but for lack of the point I'm making, or for the purpose of the point I'm making, let's call it trichloral. There's that standard of 2.0 micrograms per cubic meter with a red line. And what you see here is over the course, that's basically 90 days of time, by the way, on the bottom axis. What you see is there was one exceedance that went for 24 hours above the 2, but over the 21-day period, it was much less than 2. So here's an example where if you're following Region 7's criterion, then this would have been an exceedance of concern. If you're following a state that worries about a 21-day period, it's not. So this is what you get with the continuous monitoring or high-res data. You get to see these types of situations. You'd probably be more concerned about the 24-hour one if it was happening many times. All right, here's a warehouse, an active warehouse where they're making parts. And what we see here is this is trichloral. Now, you probably can't see on the y-axis, but these values are going up to 300 to 500 micrograms per cubic meter. And here we are getting these huge hits every day, which we later coupled to sub-foundation pressure. And these huge hits were going way over 300 to 500 for way over 10 to 15 minutes. Is that enough of an exposure or concern? Here's a situation where we knew we had some indoor air detections at around 2 of trichloral. There were floor drains. We wanted to see really what room was contributing to the indoor air that we were seeing in the building. So we closed up rooms. We then monitored different rooms, closed them up overnight, and we were able to determine over 12 hours which rooms we were getting the highest buildup over time. Those happen to be the rooms with the floor drains. So the point here is that we were able to determine over a period of roughly 15 hours which rooms were the major entry points from in this building, of the major TC entry points. Here's where we went to a single family residence where they had an SSD and air filtration units already running, but they still were getting, even after those two remedies were in place, they still were getting detections, low detections of trichloroethylene. Well, that was a problem. Trying to go out there once a week or once whenever with SUMA canisters wasn't giving them enough high resolution data. So out we go with a monitoring system, and look what we find. This is the first 7 days. This is with the air filtration unit running in the beginning, and then we turned it off where you see the red arrow. The SSD was running over these 7 days. So what's going on here? Well, when the air filtration unit was running, it seemed to cut things down, but still was right above that allowed value of 2. Who lived in this house? A young couple with a young baby, and the mother was planning, or the wife was planning on getting pregnant again. Well, this is just too close for comfort, right? 2 being the standard, and they were right about 2. All right, so then, now when the people were removed from the house for the purpose of this testing, so now what we did was turn the air filtration units off just to see what would happen, and look, values went up, but now we start seeing this daily sinusoidal pattern. How do you like that? A variation of about a factor of 3. So the air filtration units, when they were working, were, yes, they were cutting down the values, but not low enough. And remember, the SSD was running this entire time. The SSD obviously wasn't cutting things down low enough, even though they measured vacuum underneath the total slab, and they felt that the SSD was covering the total slab. All right, well, here's 30 days of time. There's the air filtration unit again at the beginning, down around 2. There's the data I showed you in the middle, which was with the SSD running. Then look what happened. We turned the SSD off, and the values went down. The exact opposite of what you would expected. How do you like that? So, of course, what this tells us is, wow, if you have an SSD running, just going out and measuring that the fan's running or that it's producing a vacuum at the manometer just may not really be telling you whether it's really doing its job or not. All right. I'm going to probably end with this one since I have 2 minutes left. I want to tell you this because this is a situation where a manufacturing factory facility that was manufacturing furniture, they had these very high hits of trichloroethylene. Initially, when they did SUMA canisters, the consultant had concluded that maybe the women's restroom was the source of the TCE. So what did they do? Because they knew they had TCE below the building, so they just assumed that it was coming up, that it was vapor intrusion primarily through the women's restroom through all the penetrations. So what did they do? What was the action that the short-term action? Remember, urgent response. They closed the women's bathroom, and they instead brought in porta potties and put them out in the parking area. And so for a period of time, the women had to go out and use the porta potties rather than the bathroom. Well, you can imagine that probably raised some questions. And as time went on with this site, they finally brought us in to do some monitoring because we were trying to decide, was this coming from below or could it possibly be coming from the factory itself, from what they were doing in the factory. The consultant had a good survey of all the products they were using, couldn't really find any with trichloroethylene in it. So, you know, what's the deal? Okay, so in we came. We started the system at 5 p.m. The idea was this, that if it was coming from the factory operations, we should see it go up during the day. If it was coming from vapor intrusion, when the factory was closed up at night, everything was closed up, all the doors, windows, everything, then we should see it go up overnight, just like we saw in that previous slide with the VOC entry and the drains. All right, so we start at 5 p.m., and look, everything's low until the next morning. At 7 a.m., we get a bump. And then we get another bump later in the afternoon. At 5 p.m., look what happens. It goes back down until 7 a.m. the next morning. And then we get these huge bumps again. And then, of course, at the end of that day, back it goes down to basically zero. All right, so what was this telling us? This was telling us that, indeed, higher values were occurring once they started that factory up at 7 in the morning and until they closed at 5 p.m. So what was causing it? Where was it all coming from? Well, it turned out that they were using, to lubricate their machines, they were using a silicone spray that some of you probably have in your house. Well, looking at the back of the can, there was no mention of TCE. No one would have thought for a minute TCE was in the silicone spray. I certainly did not think that. But just because it was ubiquitous and we were trying to figure out where the TCE in the factory was coming from, I took that silicone spray and I basically sprayed it into the inlet of my instrument. And what happened? I got a massive hit of trichloroethylene. So there you go. That's how having high resolution data can help you sort out some of whether a indoor source is from below or not from below or from inside. And we were able to do that really within 24 hours. All right, I've used up my time, so I'm not going to go through these next two. I'm going to instead just say quickly that here are some upcoming courses on vapor intrusion. Those of you who want to, we're giving one next week in Baltimore. If you want to jump in at the last minute, send me an email. I'll see if we can get you in. ITRC is giving one in October. I assume it's in Lansing, Michigan. And then the Michigan DEQ is having a third day specifically on Michigan's guidance. I would think that would interest anybody, that third day for sure, on anybody that's doing work in Michigan. And then in 2018, we'll be giving this course again. Go to my website, send me an email if you want details. And I think with that, I get to turn it over to Hieu.
All right, thank you, Blayne. All right, I will jump into a discussion with vapor barrier coating system for an existing building. In our agenda, we review how to mitigate existing structures using retrocoat vapor barrier system. Then go into evaluating the barrier physical and chemical resistance properties of what makes the retrocoat a suitable candidate for vapor intrusion. We will also go into details on how to calculate the diffusion coefficient based on land science unique testing methods and use that diffusion coefficient to calculate an attenuation factor based on the site-specific conditions. Lastly, we will look at case studies on how retrocoat has been installed on an actual site at various locations in the country. First, we wanted to define the problem, looking at an existing building where there are potential advection or diffusion through the concrete slab. Concrete composed of cement, coarse aggregate, sands, and water. There are many case studies and publications shows that permeability of concrete increases with its aggregate size. There are other studies shows that concrete with water to cement ratio of 0.28 to 0.4 contains approximately 15 to 25% voids. What that really means is concrete breathes through over the course of the life of the concrete slab. Especially one of the interesting facts is that cement, especially calcium-based cement, is soluble in water. Imagine your site or concrete slab is exposed to nuisance water, irrigation, or even hydrostatic. The amount of pore space or concrete will be dissolved into the water, thus give you a lot of pore space over the course of the lifespan of the foundation. What we're proposing is the uses of retrocoat and its ancillary to essentially seal the concrete slab and provide it a protective coating over the top. The process of installation will be installing a retrocoat gel or caulk around any cracks and joints, especially expansion joints and control joints. The concrete surface will then get a surface profile using diamond grinding or shot blasting. After that, it will be installed within 6 to 10 mils of primer, then 2 10 mils of retrocoat. What the floor will be getting is a highly and chemically resistant coating on the top that has been approved by multiple regulatory agencies. Retrocoat is also customizable for constructions and also aesthetics. What that means is the uses of sand and silica, along with paint chips and different pigment, allow the user allow retrocoat to be coming in at various colors and desirable looks. The product itself contains no VOCs and is 100% solid. It can be used as a wearing surface. When I mention wearing surface, there are physical properties we want to review for consider something that for our normal day-to-day operations. We look at bonds. Bond is an effect of chemical and mechanical bond. Looking at mechanical bond is an adhesive qualities of the material and the surface area that's used for adhesion. What you see coming up here is a line that is approximately 3 inches long. And the line below that is 6 inches long. Both lines fit in the 3 inches line. However, because of the profile that the concrete has, it will give that additional surface area for adhesion. A typical retrocoat application would need an SP3. In same term as an 80 grit surface. The other properties we're looking at is the chemical bond. It's a unique material characteristic of a modified novolactic epoxy that retrocoat has. It has been specifically blended for improvement in chlorinated solvent diffusion and also provide a durability that a coating can be used as a wearing surface. What you see on here is a picture of a piece of tile where we install retrocoat directly on top. Once we try to break away the retrocoats from the tile, it literally takes away the piece of the tile to show how well the adhesion retrocoat has onto the tile. Next, we want to look at the tensile strength and the elongations for retrocoat. Notice that tensile strength measures the lateral strength of the coating and how resistive it is from being pulled apart. And the elongations as we have is approximately 6%. Look at the results we see for the tensile strength. It's at 9,800 psi. That's approximately double the typical concrete strength in comparison to retrocoat. The elongation of the product shows that it is resistive against cracking from standard thermal expansion and contractions. The other properties we want to review is that the flexural strength of the coatings. At 7,000 psi, the membrane will be able to handle a axial load that's applied on top of it and will not crush under pressure. So you can see the picture on the right-hand side, which shows a way of a forklift operating on top of retrocoat, along with the forks and fronts, which operate oftentimes, which is drop it on the ground, which I want to lead to the counter impact resistance that retrocoat has. The strength of the coating to be able to withstand weights dropping on top of it, allow it to be more durable for your day-to-day operations. Next, lead us into a chemical resistant properties. You can see on the right-hand side is a 5-liter round bottom flask with 2 different ports on each side. The one on the left shows where the operator can inject more TCE or PCE into a water mixed TCE bath underneath. The right-hand side is an air sample port where the operator can pull out air sample and estimate the concentration of the contaminant in the airspace. Above that is 2 plates that sandwich retrocoat in the middle at a thickness of 20 mils and the diameter of 6 inches. Above it is a top chamber with 3 different ports. The middle port is an air sample port where a sample will be taken and bring into the test based on the concentration of the chlorinated solvents inside. We also introduce an air exchange rate with an inlet and outlet air through that top chamber. Essentially, it can flush out the contaminants to achieve a constant concentration gradient between the top and the bottom below the slab. What the operator will be testing is the concentration, the top and the bottom, and we have tested this at 4 different concentration challenges at 500, 250, 125, and 25 parts per million. This test has been ran for 150 days. Each day, there are two different samples that have been recorded, beginning of the day when the operator will come in, and at the end of the day after 8 hours. What we see as a result is using the diffusion coefficient of fixed laws, which outline mass over time, equal diffusion coefficient time change in concentration over thickness time area. When we simplify that equation, we get more of a straight line equation with J as the flux and diffusion coefficient time concentration over thickness. That straight line path is what we see on the results for the transport rate for PCE across 4 different concentrations. What you see on here are at steady state, based on the result that we received for a 4-week durations for each different sample twice a day, we achieve steady state after a 2 weeks window. Use that steady state number as an average to graph this plot. The result shows that a linear path for diffusion rate is that straight line go to all the points. We see a really good correlation between the results of 25 part per million up to 450 part per million. The same was plotted for TCE. However, we do see an outlier points that's lower than expected. Based on the result we saw with PCE, we were confident that the result would be very similar in that linear path. As the result, the diffusion coefficient were calculated very close to one another for PCE and TCE, which is in the range of 10 times 10 to the minus 14 meters squared per second. Notice that the numbers are fairly low in comparison to other coatings or barriers out there. What we can do with this diffusion coefficient is use that in different models, either J&E model or visual model that Blayne has mentioned earlier. A lot of it is just use site-specific data and information and use the diffusion coefficient of retrocode to enter in the model to calculate an estimated indoor air concentrations. For example, the model we have here is J&E model where we're able to enter in a contaminant type, its concentrations, where it's located, and also the air exchange rate. Once all of the parameters site-specific will enter, we can also use an effective diffusion coefficient of retrocode into the model to calculate the overall effective diffusion coefficient of the site. What that does is give you a concentration of inside the building. For this hypothetical site that we've used here, that the concentration inside the building is at 1.9 times 10 to the minus 2 microgram per meter cube. The initial concentration was at 5.6 times 10 to the 4th microgram per meter cube. If you do an attenuation factor ratio of the two, you get 3.38 times 10 to the minus 7. Notice that the attenuation factor is a lot lower than what you would expect for a coating above the concrete slab. With that, we want to conclude into some of our discussion is that standard concrete slab contains approximately 15 to 25% voids or pores, and retrocoat's physical and chemical properties shows that it is unsuitable for wear and tear substrate, and it is forklift able or drive able substrate after it's completed. With the low diffusion coefficients that retrocoat has for TCE and PCE, we were confident knowing that retrocoat is resistive against these chlorinated solvents. And additionally, the users of diffusion coefficient are able clients to use in various models, either J&E model or visual model, to calculate for an attenuation factor. In regard to risk, we do have various case studies. I'll put one on here as an example where retrocoat was installed on a former jazz club, commercial property. It was in Renton, Washington. The initial results for the chlorinated solvents concentration were approximately 5 times the screening level. Retrocoat was installed both at the slab level and walls, shows that the result was much lower than the screening level at the end. There are various and many more case studies that are available on our website at Land Science. Those are accessible on the links attached there. Additionally, we do have other state-specific guidance documents that can be reach or link to at the link below. Our team at Land Science at the very bottom can assist your team and answer questions regarding to the performance of the barrier retrocode, and also answer any question on specifications that you might need. With that, I want to hand over to Blayne for quick notes, then we'll open for questions.
All right, great. Thank you, Hieu. Yeah, that's going to conclude the formal section of our presentation. So at this point, we'd like to shift into the question and answer portion. Before we do this, just a few quick reminders. First, you'll receive a follow-up email with a brief survey. We really appreciate your feedback, so please take a minute to let us know how we did. Also, after the webinar, you'll receive a link to the recording as soon as it is available. All right, so let's circle back to the questions. We have a lot of questions, so if we are not able to get to your question, we will follow up with you after the webinar. All right, so the first question here is for Blayne, and the question is, how does one collect samples for radon analysis?
All right, I'm assuming you can hear me from here. It's actually very, very simple to collect the radon samples for radon analysis. You can use Tedlar bags because the radon molecule is so large it does not diffuse to the Tedlar bag. And so all you have to do is collect an indoor air sample using a Tedlar bag and a syringe, and the same for a subslab sample. You have to have one of both because that's how you calculate the attenuation factor. And then the key then is where you send them for analysis. And you can either send them, call up H&P, Mobile Geochemistry, and they can handle it for you, or you can email me and I'll try to handle it for you. The analysis is actually done at a university in Los Angeles.
Okay, great. Next question is for Hieu. Hieu, the question is, are there any QA/QC processes to ensure retrocoat was installed in accordance to manufacturer's specifications?
So the QA/QC process for retrocoat is able to determine the vapor moisture drive underneath the concrete slab. That will be done by using the calcium chloride test. And along with that, when retrocoat is being installed, there are wet mill thicknesses gauge that can be measured to ensure the correct thickness was installed for both primer and retrocoat.
Okay, great. Thank you. Next question here is for Blayne. And Blayne, the question is, if detected analytics exceed indoor air screening levels, is there anything further that can be done to assess risk, or should we run straight into a recommendation for remediation/mitigation?
Yeah, and that's such a broad-based question that I'm not going to be able to give really a complete answer. It really depends upon what the compounds are. You have urgent response for trichloral, but not for tetrachloral. So we're not as concerned about if it's a tetrachloral site. Well, yesterday I was on a site where we had both trichloral and tetrachloral, but in one building there was no tetrachloral or trichloral. So the options for the building with trichloral, you're going to have different options for them because you're worried about that urgent short-term TC issue than you are the other building. So it really depends. If the values are very, very high, you might jump just to mitigation, preemptive mitigation at that point. So it's very much site and compound specific.
Okay. All right. The next question here is for Hieu. Hieu, the question is retrocoat UV or efflorescence light resistant or stable? Will it change color over time?
That is an interesting question. Most, as we understand, that epoxies are not as UV stable. The colors and the pigment of the epoxy can change over time in the ways that it would amber in the course of UV exposure. There are different scenarios where we would install a protective layers of urethane-based coating over the top of retrocoat to ensure it is resistive against UV and also it's a protective coating for the course of the life of the epoxies.
Okay. All right. Next question. This is one for Blayne. The question is, what is the detection limit for TCE on your continuous monitoring instrumentation?
The detection level for TC for trichloral and for tetrachloral, 0.5 0.5 micrograms per cubic meter, which is equivalent to the 1 in 1 million cancer risk level.
All right. Okay, let's see, next question here. This is a question for Hieu. And Hieu, the question is, how do the chemical resistance properties of retrocoat compare to other over-the-counter epoxies?
Retrocoat, it is a unique blend of modified novolac epoxies, and that has been specifically designed for chlorinated solvents. So keep in mind, there are hundreds or even thousands different formulas for epoxies, and they blend differently. There are other, I guess, solvent-based epoxies comparison to a non-solvent-based epoxies. So for us, we can only speak for ourselves, but based on the testing that was shown on the diffusion coefficients, the results were much lower than expected, and it showed great results for retrocoat, that specific formulation. We can't speak for other formulation that's out there, but the result shows that this specific formulation is the key success for retrocoat.
Okay, great. Thank you, Hieu. Let's see here. Next question is for Blayne. Blayne, the question is, does the default attenuation factor of 0.03 apply to both sub-slab soil gas and deeper soil gas? If both, how deep in the vadose zone?
Okay, EPA applies it to both subslab and exterior soil gas. I used to think it was only for shallow soil gas, meaning 5 feet or less, but I believe, and someone can correct me, that it applies to all depths of the soil gas in the EPA guidance document. I do know, for example, in some states, they are also applying the subslab and exterior soil gas. For both of those media, they're using 0.03. You would have to check each state's individual guidances or policies to be sure about that.
Okay, great. Thank you, Blayne. Let's see here. Another question. This question is for Hieu. And Hieu, the question is, what is the estimated lifespan of retrocoat?
Okay. Retrocoat is as I mentioned, is used as a wearing surface. The lifespan of retrocoat will depend on how much it's been used. What we typically see for standard warehouse or industrial use with forklift traffic, approximately between 1 or 2 years. What's great about retrocoat is it can be coated directly on top of the existing coating. So the lifespan of it can be improved or increased with additional coatings on top of it. A lot of it depends on the amount of usage and abuse that the floor is going to be experiencing.
Okay, great. Thanks, Hieu. Let's see, next question here. This is a question for Blayne. It's probably going to be our last question. The question is, what was causing the daily cyclic pattern of TCE at the residence?
Well, as best as we could tell, since I was not collecting that type of data, but it appears to be correlating with wind speed. And when we had a high wind speed, we were seeing higher concentrations. The concept behind that is when you have a high wind speed, it essentially creates a Bernoulli effect, so it depressurizes the house relative to the subsurface. So that's what we believe, but because I was not collecting the climate data, I can't tell you for sure. I will tell you that with the vapor safe monitoring system now, we have incorporated into, besides chemistry data, we also now collect barometric pressure and sub-foundation pressure, and we can collect things such as wind speed to try to find a cause and effect.
Okay, great. Thank you very much, Blayne. That is going to be the end of our chat questions. If we did not get to your question, someone will make an effort to follow up with you. If you need immediate assistance with a vapor intrusion solution from Land Science, please visit landsciencetech.com to find your local technical representative, and they'll be happy to speak with you. For more information about Dr. Hartman's vapor intrusion services, you can visit hartmaneg.com. Thanks again to Dr. Blayne Hartman and to Hieu Nguyen, and thanks to everyone who could join us. Have a great day.